Welcome to section 2.1.2, and this section talks about rebound ratios. Now these next two lessons are lessons I'm actually pretty disappointed that we're not in class together to work on these, because it actually has a nice lab that goes with it, and it's usually a pretty fun lab for most people. It requires dropping bouncy balls and calculating the rebound ratio. Now the rebound ratio at the bottom of the page, the rebound ratio, should have moved that up. The rebound ratio, that's going to be the rebound. That's our bounce height, how high the ball bounces, over the initial drop height. Now for this to work, make sure we have the same units for the initial height and the drop height. Don't calculate one in feet and the other one in inches. It wouldn't work that way. You need to make sure your units are the same. So what we're going to do is we're going to calculate the rebound ratios of these objects. For a tennis ball, it's got a rebound approximately 111 centimeters when dropped from 200 centimeters onto a granite block. And these are just what they use to test if the tennis ball bounces the proper way for it to meet requirements. So the rebound ratio is going to be the bounce, which is 111 centimeters, over 200 centimeters. And you can see the units cancel out. And we divide that, and we go 3 decimal places, 0.555. That's the rebound ratio for a tennis ball. For a soccer ball, the rebound ratio is going to be 120 centimeters over 200 centimeters. And this one's with steel plate. Don't ask me why. So that's going to be 0.6, because the units cancel out. For a basketball, it doesn't matter that the other two are in inches and this one is the other two are in centimeters and this one's in inches. The ratio is going to be the same, because what's going to happen is the units are going to cancel out, and that's all that's important. So it's going to bounce 53.5 inches over 72 inches. The units of inches cancel out. So the rebound ratio is 0.743. And for a squash ball, 29.5 inches is our drop. Or rebound over 100 inches is our drop. And when we divide that, we get 0.295. Once again, those units canceled out. So if you look at the ratios, the bounciest one has the highest rebound ratio, and that is the basketball. So the basketball is the bounciest. That's going to rebound the most out of all of those objects. And that is rebound ratio. So when we're talking about these, if we were to graph this, if we were to work with these, what you would see, kind of just ignore that, what you would see, starting at different heights, if you start at a low height, so on this x-axis, here's our rebound. That's our dependent variable because it depends on the height that the ball is dropped. And our independent variable is going to be the drop height. So what happens is, if we drop it from 0, it doesn't bounce because it's on the ground. Then, if we drop it from a height like this, it's going to have a lower rebound height here, 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 and here. You'd have to see the values, but what it's going to be is it's going to be a linear graph. This is going to be a linear graph because that rebound ratio stays constant no matter what. So if we were to write the equation of this line, kind of skipping around a little bit, y equals r times x, where r is that rebound ratio. So the rebound ratio for our teams, we don't have any data to use. All we're worried about there is that y equals r times x. And for the rebound ratio for this model, it's linear. Once again, I'm sorry we weren't able to do a lab for this. Unfortunately, that's something that had to get cut. But that is rebound ratio. It's the rebound height over the drop height. That's all we're looking for in this lesson. We'll be back with another one and talk about what happens if we let the ball continue bouncing.